Здравствуйте.
Hello, everybody.
Сергей Александрович, добрый день. Вы меня слышите? Это Наира из учебного офиса.
Да, добрый день, слышу.
Хотела бы спросить у вас, я узнала, что у вас сегодня после пары консультация со студентами вашей группы.
Да.
Можем ли мы эту консультацию перенести на другое время, потому что у студентов сегодня сорвалась пара, лекция очень важная, и переставить туда лекцию, если возможно, конечно.
Да, конечно, возможно. Это один раз или это вообще?
Да, нет, только сегодня, только сегодня.
Хорошо, мы тогда с ребятами как-то договоримся, когда ему будет.
Ну, вы можете после окончания лекции консультацию провести, как вам удобно.
Это будет через пару, да? Ну,
Да,
сейчас
в 6 часов.
Поговорю, если им это будет удобно.
А вы консультации в каком формате проводите? Опять же в Zoom после пары?
Опять же в Zoom, да.
Но свой Zoom используете?
Да,
или...
я, в принципе,
Ага.
если у вас, в принципе, занят, то есть есть дефицит, то у меня есть свой лицензионный аккаунт, ну, в смысле, я там купил лицензию, и я вполне могу со своего, в принципе, вести. Но если...
Нет, он у нас не занят, я могу, если вам нужно, я могу сделать консультацию, как вам
Нет,
удобно.
консультацию я тогда уж точно со своего, мне удобно их действительно переносить, иногда нужно. Вот, а это тогда пусть... У меня только еще один вопрос к вам технический.
Да.
Записи семинаров доступны ребятам?
Я могу... Дело в том, что ко мне обратился по поводу записи только Трушин, чтобы я их выложила в YouTube. Они все выложены.
Вот
И лекции, и семинары. Если вам нужно, чтобы и ваши были выложены, тогда...
Наверное, здорово будет, чтобы и мои тоже были выложены. Ну вот для моей группы, чтобы они были доступны. Если можно.
Хорошо, попробую тогда сегодня или завтра это сделать.
Спасибо большое.
Все тогда. Когда удачи, я отключаюсь, тогда вы сообщите. Ребята, вы меня слышите все? Сегодня будет в 16:40 у вас лекция у Шершаковой. Сейчас информацию отправлю на почту. Будьте добры присутствовать. Извините за вторжение, спасибо.
По домашке вопрос можно тогда? Серьезный, там второй номер не понравился. Как, если завтра дедлайн, консультации если не будет?
Так, значит, ребят, давайте, да, по-русски обсудим, потому что я...
Не слышно вас.
Извините. Итак, давайте по-русски обсудим, быстрее будет. По поводу консультаций. Значит, вот у вас сейчас лекция. Хотите после лекции сделаем консультацию сегодня? Или
Так у нас же лекция Шишакова, нет?
Ну, в смысле, она после лекции. После нее.
Ну, это не имело бы смысла.
Давайте я тогда кину вам на почту ссылку на конференцию и проведу консультацию после лекции, чтобы мы сейчас не тратили время на разбор домашки. Нормально?
Да, спасибо большое.
Да.
Окей. Тогда перехожу на английский и кидаю ссылку на доску, как обычно, и тогда займемся новым листочком. Okay, this is the link to our board, and I will try to show it. Yes, now you see my screen, and you can write. Okay, then we have consultation after the election, which is after this seminar. So consultation would be at 6:10. Yes. No. Okay. And now let us start with. I'm sorry, there is a problem. I'm sorry, I have a little bit technical problem. But let us try to start. And the first question is find all elements of order 16 in the group Z17. I'm sorry. Oh. Так, все прекрасно работало, пока не нужно было. Sorry, let's begin. And the first question is to describe all elements of order 16 in Z 17 star. Unfortunately, I can't write. Sorry. Okay. now we can proceed. And this group. Let us remember what the group Z17 star is. This is, okay, I'm sorry, you hear me, yes?
Yes, we do.
Thank you very much. We have the set of all reminders Z17. This is the set of all reminders modulo 17. And Z17 star is all reminders except 0 with operation multiplication. So it consists of 1, 2, 3, so on, 16, and we multiply these elements. So we need some elements of order 16. Let us try to find one of them. First of all, the first question is what is the order of element 1? This is the simplest question. Order of element 1 equals to, what do you think about it? Maybe
zero, is it?
no, 0 cannot be because order is.
Then it's 1. Then it's 1. Yes.
Yes, 1. Order is a natural number, the minimal natural number, such that the power of our element equals to unit, to natural element. So natural element in this group is 1, and the order of 1 is 1 because 1 is the first power equals to natural element. Okay, let's try to find the order of 2. How to find the order of 2? We understand that order of any element divides the order of group. And our group consists of 16 elements. So the possibilities of order X are 1, 2, 4, 8, and 16. One is the order of the unique element 1, and other possibilities can be. So how to understand if the order of 2 is equals to 16? If the order of 2 equals to 2, 4, or 8, then 2 in power 8 equals to 1. If it is true, then the order of 2 will be 1, 2, 4, or 8. And if it is not true, then the order of 2 equals to 16. Is it clear? So the question is, if 2 multiplied by 2 8 times equal to 1. Equal means that the remainder of this element equals to 1. So let us try to find 2 in 8th power. So 2 square equals 4. 2 in the 4th power equals 4 in 4 square. It is 16, and if it is convenient to say that 16 equals -1, and I'm sorry, not 4 in the fourth power. Here is 2. 2 in the fourth power equals 4 in the second power, and it equals to 16. And 2 in the eighth power equals to minus 1 square, and this is equal to 1. So the order of 2 equals to 8. And 2 is not an element of order 16. Okay? If you have some question, please ask it. So 2 is not the case, so let us try 3. Let us examine the number 3. 3 square equals 9. 3 in the fourth power equals to 9 square. This is 81. And let us divide 81 by 17. It's rather difficult. I will use some device. I'm sorry.
That's 13, I guess.
That's 13. Okay, thank you. 13. And then 3 in the 8th power equals to it's equals to 13 in square. It is equal to 169, and this is equal to, for example, 39. I just 130, of course, is divisible by 13, and this is this is divisible by 13, so this is, I'm sorry, this is 17 is my model, so this is not the case. This is equal to -1, because of course this is divisible by 17. So this is -1, and then only 3 in the 16th power equals to 1. So we find the first element which is of order 16. This is 3. Order of 16 equals to, I'm sorry, order of 3 equals to 16. Of course, we can examine every element from 1 to 16 and find all elements of order 16. But let us try to do it more convenient, in more convenient way. Let us find all the powers of 3. We find one element of the order 16. All the group has order 16. So what we can say about this group, Z17, it is isomorphic to what? if there is a group which is of order 16 and one of the elements from this group is of the order 16. What can we say about this group? If there is an element of order equal to the order of the whole group, then this group is cyclic. And this is isomorphic to Z16. Is it obvious? Is it clear?
But what about 0 in the Z16?
In Z16, we have other elements from 0 to 16. And these elements is from 1 to 7. I'm sorry. In Z16, we have elements from 0 to 15. And this is in Z17 star, the elements from 1 to 17. And the isomorphism from one to another group, it is not very simple, so we must to understand, yes, thank you very much, 16, the last element of Z17 star. There are 16 elements in the left, and there are 16 elements in the right. And this group are isomorphic because the right group is cyclic and the left group is also cyclic. Okay? But our goal is to understand what is the isomorphism between these two groups. Okay, let us try this yellow curve is not in the one of, I don't understand how to erase it. Okay. We have understand that Z17 star is a group with generated by 3, because the order of 3 is equal to 16. So let us try to understand the isomorphism between Z17 star and Z16. Of course, the neutral element on the left is 1, and the neutral element on the right is 0. And since we want the isomorphism is homomorphism, then 1 goes to 0. This group is generated by 1. So the generator of Z17 star we map to 1 to the generator of Z16. So 3 maps to 1. And then we can understand all the elements, because 9 goes to 1 plus 1 goes to 2. 27 goes to 3, but 27 equals to 10, yes. 10 multiplied by 3 is 13, which is equal to 13. and it goes to 4, and so on. Do you understand the rule of this mapping?
Yes, it's clear.
3 in power k goes to k. Okay, and if we have this isomorphism, of course we must to proceed and to find images of all the elements. Since the order of 3 equals to 16, then on the left we have all elements. And then let us solve more easy task. What are the elements of the order 16 in Z16? Let us change the frame. Number 4. Okay, we have Z16. Let us just list all the elements 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I will write in another color the orders of this element. The order of 0 equals to 1, because 0 plus 0, just 1 mass, equals to 0. What is the order of 1?
This one.
No, the order of 1 is 16. This is the group with addition. And how many times shall I add 1 with itself to obtain 0? 16 times, because we have only 16 equals to 0. But elements from 1 to 15 are not equals to 0. And what is the order of 2?
8.
The order of 2 is 8, because 2 is an even number, and we add itself is it add with itself 8 times, and we obtain 0. The order of 3. What is the order of 3? If we have k multiplied by 3 is divisible by 16, what is the minimal k? Of course it is 16, yes? The order of 4 is 4, the order of 5 is 16, and so on. Here 8, 16, 2, 16, it seems that 8, because 10 is divisible by 2, but it is not divisible by 4. 16, 4, 16, 8, 16. Okay, all odd numbers has the order 16, and all the other numbers has the order less than 16. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8 elements of order 16. And if we want elements of order 16 not in the 16 but in the 17 star, we need this correspondence between Z70 star and Z16. We have also, of course, 8 elements of order 16 in Z17 star. This is elements 3, 10, and so on, all the elements which corresponds to odd numbers in Z16. Okay, is it clear? Are there some question concerning this task? Please, if you have some question, then
Can you repeat like the wivot, because I didn't get it about the odd numbers, the last one.
okay. I haven't found all the elements from Z17 star because it's rather long time to find all of them, but I understand that this is 3 in the I'm sorry, in odd powers.
Like why? Why like odd?
Why? Because we have isomorphism from Z17 star and between Z17 star and Z16. And we understand what is the elements of order 16 in Z16. This is just odd numbers.
Oh yeah, I get it.
And so we find the elements from Z17 star which correspond to these odd numbers in Z16. And the correspondence is that the number k in Z16 corresponds to 3 in power k in Z17 star. So the answer is 3 in all odd numbers, but if you want, you can just find all of them. You just proceed with the same rule. So the next element is 13 multiplied by 3. This is equal to 39, and this is equal to 5, it seems to me, modulo 17. So 5 is also 3 in the odd number, in the odd power, and it has the order 16. And so all of them are 8 elements. We find 3 of them, and if we proceed, we find all the others. Okay? Okay, let us begin with the second problem. The second problem is find all elements of order 11 in the group Z11 star. I don't know if this is a joke, but it is, if there is no mistake in this question, then it is very, very simple. Okay, we have Z11 star, and we need elements A from Z11 star such that A, the order of A equals to 11. What do you think? How many such elements we have? What do you think about the order of this group?
10.
Yes, it is 10, of course. And you understand that order of any element divides the order of the whole group. So if this is 10, then this cannot be 11. So there are no elements of order 11 in Z 11 star. But
And why is it so? Why the order of any element has to divide the order of the whole group?
okay, this is a corollary from Lagrange theorem. Lagrange theorem says that if we have a group and a subgroup, then the number of elements of G is divisible by the number of elements in H. And if we have G and an element G from G big, then we can consider the cyclic subgroup generated by G small, and then the order of this group equals to the order of G, and this is equal to, I'm sorry, this is not equal, this divides the order of the whole group. So we obtain the assertion that the order of an element divides the order of the whole group. But I think that there is a mistake in this problem. I think that it should be 10 here. And then this problem is very similar to the first one. So we have, let me explain it in the next frame. We have Z 11 star. We have the order of this group is 10. And if you want to describe all the elements such the order of A equals to 10, then you find one of them. Then you say that Z11 star is a cyclic group which is isomorphic to Z10. In Z10 you find all the elements from 0 to 9. Their orders are 0, oh, I'm sorry, not 0, of course, 1, 10, the order of 2 is 5, the order of 3 is 10, the order of 4 is 5 also, the order of 5 is 2, the order of 6 is 5, the order of 7 is 10, the order of 8 is 5, and the order of 9 is 10. Let me explain. For example, I want to understand the order of, for example, 6. I understand that this equals to k, and k is the minimal number such that k multiplied by 6 is divisible by 10. Of course, k should be divisible by 5, but if k equals to 5, it's okay. So the order of 6 is 5. So let us find one of the elements of order 16. Oh, sorry, 10. Now we proceed just by brute force. 1 has order 1. 2, let us try. 2 multiplied by 2 is equal to 4. 2 multiplied by 4 is equal to 8. 2 in the 4th power is equal to 16, and this is 5. 2 in the 5th power is equal to 10, and this is -1. So we understand that the order of 2 is divisible, divides 10, but it is not equal to 5, and it is not equal to 2. So it is 10. So the order of 2 equals 10. And then we obtain the correspondence between Z11 star and Z10. Let me write it down. So this is Z11 star, and here is Z10. We have 0, 1, 2, 3, 4, 5, sorry, 6, 7, 8, 9 here. And we have the images of them. This is 1. This is we have find an element of order 10, and this is 2. Let us map 1 to 2. Then 2 maps to 4, 3 maps to 8, 4 maps to 16, which is equal to 5, 5 maps to -1, which is 10, then 6 maps to -2, which is equals to, I don't know, 9. 7 is -4, which is equal to 7. 8 is -8, which is equals to 3. And 9 is maps to 3 multiplied by 2. I'm sorry, it should be 1 here, but 3 multiplied by 2 equals to not to 12, but it's okay. Here is 6, and it's okay. So we have understand that in Z10 the elements of which has order 10 is 1, 3, 7, and 9. So here we are interested in 1, 3, I'm sorry, 7 and 9. 7 and 9. So in Z11 star, the elements of order 10 are 2, 8, -4 equals to 7, and 6. Is it clear?
Yes, I think.
Okay, thank you very much. Then let us proceed with the next question. Find all the generators in these 5 star is the same, but rather is the same task, but it is easier because 5 is smaller than 11 or 17. So we need all the generators in Z5 star. I would like to ask some person to solve this task. You can just say what to do to me and I will write down. So can somebody say what shall I do? I would like all the generators in this cyclic group. What is the order of this group?
4.
The order is 4. So we want all the elements of order 4 in this group. In this group, there are not very big number of elements. There are just 4 elements, 1, 2, 3, and 4. It is rather convenient to show that there is isomorphism between Z5 star and Z4, but since the number of elements is rather small, then you can just find all the orders by explicit just I don't know my English. Just find the power in which 2, 3, and 4 is equal to 1. The order of 1 is also 0 as in the previous tasks because this is neutral element. Okay, say me please, what is the order of 2, 3, and 4?
For 2 is 4.
4, okay. Because 2 square equals to 4 and it is not equal to 1. And since we understand that the order of 2 divides the order of all the group is 4, then the possibilities are 1, 2, and 4. Yes, you were right. 2 has order 4, 3.
Also 4.
Also 4, and 4?
2.
2, of course. And these are 2 elements of order, or I'm sorry, not these. These are 2 elements of order 4, and they are generators of Z5 star. The generators of Z125 star, it is a similar task, but if we have time in the end, then we return to this task. Now I want to skip it. Let us say about cryptography. Okay, I will remind you an crypto system of Diffie-Hellman. You have 2 persons which try to communicate, then they can't communicate in private form, all the communication. Here another person C with which is a thief, and he tries to understand all the information which A and B send to each other. So A publicate n number G and a group G big. Most of all, this is Z K, and this is just an element L from ZK. Okay, and A has its secret number A, B has its secret number B. Then A can find G in power A, and B can find G in power B. And B send to A this number G in power B. A send to B G in power A. Then this person Alice and this person Bob. Alice know its number A, and B sends have sent G in power B. So A knows A and G in power B, and she can find G in B in power A, which is G in power AB. And Bob knows his secret number B, and Alice say to Bob G in power A, and Bob can find G in power A in power B, which is equals to GAB. And the person C, he knows G. He knows G in power A and G in power B. But it is rather complicated task to find from this data G in power AB. The simplest way, which is known, is to find A from these two data. So we need to find logarithm, and then you find G in power B in power A, which is equal to GAB. But it is rather complicated task. So we want to say that the numbers G, A, and B are so big that it's impossible. And then A have this number G in power AB, B have the same number G in power AB, and this is the secret number of A and B, and C cannot obtain this number. Okay? I hope that you have heard it on your lecture course. So now let us deal with it in our fifth task. Okay, we have G is Z5 star. I'm sorry, I said that this is ZK. Of course, I mean that this is ZK star. This is the most convenient group. Okay, G is Z5 star, and the element G is equal to 2. And you have a table zero zero 0 1 1 0 1 1 1 2 3 3 4. Okay, this table is not necessary for the first point. Okay. You are Alice, and Bob say to you G in power B, which is equal to S, which is 3 by our conditions. You choose your secret number A, which is equal to 2. And you need to compute your secret K, which is G in power A, B. Okay, please compute me what is, I'm sorry, this is not K, this is R, but it is not important.
But what is R?
R is this number G in power AB, which we try to compute. And please compute me what is G in power AB. If you know A, and you know G in power B. What is
Shouldn't
G
be
in power
9.
AB? Yes, it's 3 in power 2, of course, G in power B in power A, yes, and should be 9, but we are in Z5 star, so 9 is equal to 4, yes. Okay, the second point is to compute. I'm sorry. R is not, this is, sorry, this is of course K, and this is this was the point B. K is equals to GAB, and this is 9, which is equals to 4. And in point A, I don't know, there is no question in point A, just you have set to be an element G in power A, and G in power A is 2 in power 2, and it is equal to 4. Okay. And the point C. The point C, you want to recover the original from some message. I'm sorry. Message is 2 3 2 1. And it seems to me that this point is rather simple, because you just recover by this table. So what is the original? Two is 0 1. 3 is 1, 0, 2 is 0, 1, and 1 is 0, 0. Just this is the original message if you obtain this one, but this point does not use all this deal with Diffie-Hellman correspondence. Okay. Are there some questions concerning the problem 5?
Isn't C like too simple? Well, it sounds. Well,
Yes, it sounds too simple, but
shouldn't we like put something in the powers for these keys? I don't know.
it seems no, because of course in practice it is a very big deal to send to you some elements, for example 2, 3, 2, 1, and point C does not say what is the way which we obtain 2, 3, 2, and 1. But if you have obtained this message, then you can recover by this table in a very simple way. It seems that it's okay. It's a very simple task, just to understand the simplest correspondence, for example, by this table. It's okay that it is too simple. Okay, number 6. Number 6, we have G, which is equals to Z17 star. I'm sorry. And we have an element G, which is equals to 3. We have F4. This is the sequence of numbers 0 or 1. A0, A1, A2, A3, and each of these elements are from the set 0 and 1. Okay, and the first point is we have a mapping pi from the set of these sequences to Z17 star. Such that this sequence A0, A1, A2, A3 goes to just 1 plus A0 plus 2 multiplied by A1 plus 4 multiplied by A2 plus 8 multiplied by I'm sorry, here is 2 and here is 3. And we should understand that this is a bijection. Can you explain that this is a bijection? Please don't be shy, talk with me. And this is a rather simple question to understand that this is bijection.
Well, I don't have a formal proof, but we can see that all the elements of G are positive, and our formula consists only of addition, so two numbers will never coincide. So,
Numbers never coincide.
because we can start from a 0 to 3, all equal to 0.
Mhm.
And then if we if we increase any number, the sum that we obtain from the formula will change inevitably. Like the number gonna grow, and obviously if we try to change the values, it's gonna be different, but it's not a formal proof, as I said.
Okay, you are of course correct. Maybe you're right. I want a little bit more formal proof, but it's okay. We understand the correspondence from the left to the right. A0, A1, A2, A3 goes to this sum. And if I have, for example, an element of Z17 star, 15, how to obtain A0, A1, A2, and A3? It seems that we should consider this number minus 1. So 15 minus 1 equals to 14. And then you can decompose this 14 by I'm sorry, I don't know how it in English, двоичная запись. So we say that this, since 14 equals to 7 multiplied by 2, then the last element will be 0. Since 7 is an odd number, then we say that it is equal to 6 plus 1 multiplied by 2. Then this equals to 3 multiplied by 2 plus 1 multiplied by 2. And this is equal to 2 plus 1 multiplied by 2 plus 1, and all of this multiplied by 2. So the last is multiplying by 2, so there is 0 here. Here multiplying by 2 and plus 1, so here is 1. Here is multiplying by 2 and plus 1, so 1 here, and 1 here, because we start with 1. So it seems that this is 14. This is equals to 14. I don't know. I don't want to explain it more precisely, because I think that you know how to obtain this form from every number. You can just divide by 2. So and it seems that this is the inverse order. This is A3. I'm sorry, let me change the color. This one is A3. This one is A2, A1, and 0 is A0. So 1, 1, 1, 0 corresponds to 15. And so we understand that every sequence of A we can map to an element of this 17 star, and every element we can map to just a sequence of coefficients. Is it clear? This shows that this is bijection. I hope it's clear, and let us proceed with point B. We want, we say that A equals to 5, B equals to 3, and we want to compute just G in power A and G in power B. Okay, please compute it. I remind that we are in the 17 star, and G is equals to 3. So you need just compute these numbers. What is the number 3 in power 5? It seems that simpler 3 in power 3. Please, somebody say what is the results. 3 in power 3, it's 27.
10.
It equals to 10, yes, of course. And this one?
Well, that's 343, if I'm not mistaken, and the...
To 200.
343 is rather complicated. It seems that this is 3 in power 3 multiplied by 9, yes? And this is 90. And then it is equal to, I don't know, what is the remainder of 90 modulo 17?
5?
Okay,
I'm not sure.
let me check.
Yeah, 5.
5, it's okay, yes? Oh. Okay, yes, it's 5 because 85 is divisible by 17. Okay, the point B is over the point C. Compute, this is R and this is S. The point C say that we want to compute R in power B and S in power A. Of course, both of them are equal to G in power AB, but the task is to compute it independently and check that we have the same result. Okay, let us compute R in power B. We have said that R is equals to 5 and B is equal to 3, so we want to compute 5 in the third power. This is 125 and modulo 17, it is equal to, for example, minus 45, and this is equal to minus 11. This is equal to, it seems to me, 6. Yes. Oh, I'm sorry. So if I haven't mistaken, that this is 6, and S is equal to 10. And A is equal to 5. We need 10 in power 5. Okay, let us deal with 10 in power 2 is equal to 100, which is 15. So 10 in power 4 is 15. It is equal to -2. So that should be -2 in squared. So this is 4. And 10 in power 5 equals to 4 multiplied by 10 equals to 14. And this is modulus 17. 6. Okay. This is just an example to have some experience with multiplying and powers in this group. Okay, number D. Number D say that we need to take the sequence 1, 1, 0. I'm sorry, 0, 1, 0, 1, 1, 0, and cut it in two pieces, S1 and S2 of length 4. So this is S1 and this is S2. Okay, they map each of pieces into H1, H2 by encrypt they by the K to get M1 and M2. This is the correspondence from the point A. We understand that from S1 we want to obtain M1, which is equal to 1 plus this is A0, A1, I'm sorry, A0, A1, A2, and A3. And so 1 plus 1 plus 2 multiplied by A1, it is equal to 1, plus 4 multiplied by 0, plus 8 multiplied by 1. It is equal to, let me see, 2, 4, 4 plus 8, 12. So M1 equals to 12. And please, what is the volume of M2?
6. Must be 6.
Yes, no. This is 1 plus 6. Yes, of course, this is 7. Yes. 1 plus 2 plus 4 equals to 7. Okay. And the last task, number E. Decrypt the elements M1 and M2 in order to recover the original elements and obtain the original sequence S. Please let me think about it. Decrypt the elements M1 and M2. I'm sorry. In it seems that there was an algorithm how to decrypt. On your lectures, is there an algorithm how to decrypt some elements? The original sequence S. I don't understand this point. I'm sorry, let me think about it. Decrypt the elements M1 and M2. Original.
Isn't it like just D, but like in the reverse?
Okay. Okay, I understood, of course. Thank you very much. This is just a very simple question. I'm sorry. M1 equals to 12, and M2 equals to, I don't know, 7. Sorry. And then we want to obtain S1 and S2. And the algorithm is just to show that, let me obtain from 12 this correspondence. We say that 12 equals to 6 multiplied by 2. Then 6 is equal to 2 plus 1. I'm sorry. 6 is equal to 3 multiplied by 2 multiplied by 2. And 3 is equals to 2 multiplied by 1 plus 1 multiplied by 2 multiplied by 2. So 12 equals to 1, 1, 0, 0 with index 2. This is, I don't know how to say it in English, двоичная запись числа 12. And the algorithm is, if just multiplication, then you put 0 here. If you have addition, this one, then you put 1 here. And first of all, you start with 0 and plus 1. This is the first, so here is 1. You have 2 ones because there are 2 addition of 1, and you have 2 zeros because you have 2 just multiplication by 2. And so you say that S1 equals to 1, 1, 0, 0. Let us check. I'm sorry, because I have mistaked. We want to take 11, not 12. I'm sorry, because the algorithm was to obtain not from 11, but not k, but k minus 1. So let us start with 11. 11 is 9 plus 1. So the last element should be 1. 10 is equals to 5 multiplied by 2 plus 1. So this is equal to 2 multiplied by 2 plus 1 multiplied by 2 plus 1. And this is equal to, so we have 0, 1, then we have addition of 1, so this is 1. Then just, I'm sorry, here is the first is 1 multiplied by 2, so this is 0, then 1 and 1. Okay. Because 11 is 8 plus 2 plus 1. This is 2 in power 0, 2 in power 1, and 2 in power 3. But there is no 2 in power 2. So this is equals to 11. And this is the same as, I'm sorry. There is a problem. I'm hurry up and I have a mistake. 2 in the third, 2 in the first, and 2 in the 0. So we have that 11 is this one. And this is not the same with this one. 1 plus 2 plus 8. Because of this is the inverse, we should just swap the first and the last, because this is A3, this is A2, this is A1, and this is A0. So we have 1, 1, 0, 1, and so now we coincide with the previous one. I'm sorry for a lot of mistakes at the end. Okay, let us finish. I'm sorry that it's some mistakes. And we have consultation after your lection in 6:10, and I shall send a link on your email. So, thank you very much.
I have a question.
Yes.
2 seminars ago, you said that you're gonna post all the seminar notes from like the previous seminars, but I couldn't find any. Are there in some special place, or what?
Oh.
Because you just need to understand that it's really hard to solve the homework when you like hardly have a lot of seminar notes, so you have some written notes, but it's really hard.
Попроще было по-русски, да?
Ну, можно.
Значит, вы хотите записи семинаров, в смысле,
Да.
вот, записи именно решенных задач?
Ага.
Я, конечно, не обещал такого, честно говоря.
Ну, обещали,
раз
сказали
есть
то, что
запрос,
я
я постараюсь. Нет, это было к первому именно семинару, честно говоря. Но ладно, давайте я буду это делать. Если, ну, по крайней мере, избранных задач я буду стараться набирать их и...
Ну, вы можете не набирать, вы можете, например, выкладывать
Да.
вот эти доски, просто их нигде нет. Если их можно как-то...
Они...
Вот эти доски, я думаю, этого даже хватит. Просто когда проходит
Доски?
неделя, и ты садишься делать ДЗ, и ты совсем забыл, что происходило на семинаре, тяжело вспомнить.
Сейчас, доски вообще не проблема, то есть доски, они сохраняются по той же ссылке. Вы можете себе просто ссылки копировать, и, соответственно, они доступны. Я могу их собрать в какой-нибудь файлик.
Да, да, было бы отлично.
Потом
Если
вот
бы у нас
я
были доски к
обсуждал
семинарам.
с администрацией, и вроде как они обещали видеозаписи семинаров вам тоже предоставлять.
Ну, это было бы неплохо, но я думаю, хотя бы вот таких вот whiteboardов было бы уже
То есть
неплохо.
доски достаточно, не надо набирать там аккуратные.
Нет, набирать не обязательно. Я думаю, то, что
Ну,
вот такого, в
тогда
принципе,
это
хватит.
вообще не проблема, тогда я вам пришлю подборку досок всех предыдущих семинаров, это не проблема.
Ага, ладно, спасибо. Да, до
Окей.
свидания.
До свидания.